Assalamualaikum warahmatullahi wabarakatuh and very good day everyone. So today we will continue our lesson on SEEM 4223 Embedded System, Chapter 6, which is related to the real-time interfacing. So now we are going to learn about timer, counter and interrupt. Right, first we go to the introductions. Right, so the use of timers and interrupt are always unnoticed because of the low-level hardware operation, which is hidden by the Arduino API. So basically, when we talk about timers, when we talk about interrupt, so we cannot see with our bare eyes, okay? That's why it is actually hidden by the Arduino API. So many Arduino functions such as delays, okay, where you wanted to use it to delay your LED blinking, millis, micros, where you wanted to get the current time execution of your Arduinos. Also the PWM function that you have learned in the previous class, analog write, tone, which is you have using it to sound the buzzers, no tones, whereas servo libraries, they are also use timers and interrupts. So in general, most tasks can be accomplished without resorting to interrupts, but the use of interrupt itself, it can clean up the code and add another dimension to the program. Because sometimes if you wanted to run program and at the same time you wanted to do any other things which is that we wanted to run program separately without having to disturb the main program, we have to use an interrupt lah. Alright. So the reason why interrupt is being introduced because we wanted to provide a fast response, okay, to external inputs and user interface. The second up, if we also wanted to free up the main loop for other things, okay, instead of sitting in a delay function. And then lastly, if we also wanted to provide accurate timing in conjunction with the hardware timers. Alright, so that is one of the reasons lah why Arduino is being introduced timers and interrupts in their architecture. Right, next is timer interface. Okay, so a timer or counter, it is actually like a clock, okay, and can be used to measure time events. So any event which is related to time, okay, in Arduino they are using timers, right? So the timer can be programmed by some special registers. So in order for us to operate the timer, they have their own registers. So we can configure the prescaler for the timer, okay, or the mode of operation and many other things, right? So the Atmega 328 microchip is pin compatible and only differ in the size of timer interface, internal memory. Okay, so for Arduino Uno, okay, we have 3 timers. Okay, we have timer 0, timer 1 and timer 2. Right? So timer 0 and timer 2 is actually 8-bit timer. And for timer 1, it is 16-bit timer. Okay, so you must know in Arduino Uno we have 3 types of timers lah. Okay, timer 0, timer 1 and timer 2. Timer 0 and timer 2, we have 8-bit. Okay, timer 1, we only have 16-bit. Okay, so the most important difference between 8-bit and also 16-bit timer is actually the resolutions. Okay, so it means that 8 bits, we only have 256 values or only 256 counting that we can do. Okay, which is by use the 2 to the power of 8. Alright, 2 to the power of 8. Okay, where 16-bit means we have a lot more counting, which is 65,536 values. Okay, 2 to the power of 16 equals to 65,536. Right, which is a very much higher resolution so that we can do a lot of things with 16-bit timer. So previously I just talked about Arduino Uno, but for Arduino Mega they have it is based on Atmel AVR Atmega 1280 or Atmega 2560. So they are almost identical to previous chip but only differs in memory size. Okay, but both chips for Arduino Mega, they have a total of 6 timers instead of 3 timers compared to Arduino Uno. Okay, so the first 3 timers, timer 0, timer 1 and timer 2, it is actually the same as Atmega 168 or 328. Okay, it is the same as Arduino Uno. Alright, but they have 3 additional timers, timer 3, timer 4 and timer 5, and all those 3 timers are 60-bit timer. Okay, therefore Arduino Mega, they have a total of 1, 2, 3, 4 16-bit timer and 2 8-bit timers. Right, so all timer depends on the Arduino system clock. Okay, so normally for Arduino, they are clocking at 16 millihertz. Okay, so the timer hardware can be configured with some special timer registers. So in the Arduino firmware, all times were configured to a 1 kilohertz frequency and interrupt are generally enabled. Okay, so that is the default configuration of Arduino. Okay, in general, they are running on 1 kilohertz frequency, and for interrupt, they are generally enabled. Okay. Alright, so next is timer interface. So for timer 0, okay, it is actually 8-bit timer as I just mentioned, okay, and then it is used for timer functions such as delay 1 millisecond, 100 millisecond, 1000 millisecond, and millis if you wanted to get the current execution time in millisecond. If you wanted to get the current time in microsecond, you can use micros. Okay, so if timer 0 registers is being changed, this may influence the Arduino timer functions. Okay, so if you wanted to change the registers inside timer 0, it may actually influence the timer which is running inside Arduino. Okay, so timer 1 and timer 1 is actually 16-bit timers. So usually the servo library, they are using this type of timer, okay, to conduct the servo operation. Okay, and for timer 2, it is still 8-bit timers. Okay, usually we are using tone functions. Okay, tone function usually use timer 2. Okay, timer 3, timer 4, timer 5, as I just mentioned, it is actually inside Arduino Mega. Okay, so all these timers are 16 bits. Alright, so let's talk about the timer registers. Okay, so the timer behavior can be changed through the timer register settings. Okay, so the most important timer registers are, the first one is the TCCRX. Okay, we call it timer counter control registers. Alright, so the prescaler can be configured here. So inside the TCCRX, you can configure the prescaler, which is like divided by 28 or 128 and etc. Alright, and then you also have TCNTX, so which is actually timer counter registers. Right, so where you will store the actual timer values lah inside these registers. Okay, so next is the OCRX. So OCRX is actually the output compare register. So in this register, you will compare the output, and if you choose output compare interrupt, so your interrupt will be triggered if you have some comparison in terms of output inside these registers. Okay, and then ICRX is actually input capture registers. So it is only for 16-bit timers. Okay, for ICRX, it is actually if you wanted to compare, if you wanted to capture, okay, you wanted to trigger your interrupt by capturing the pattern of your data. Okay, for example, this is rising and this is falling. Okay, if you wanted to trigger your interrupt in rising edge, you have to use the ICRX lah, interrupt capture registers. Okay, where it will capture the rising, every rising edge, they will trigger an interrupt. Right, so if you are choosing the falling, every falling pattern, okay, every falling pattern of your input will be triggering interrupt. Okay, and then next is TIMSKX. It is actually timer counter interrupts mask registers. Okay, so it is actually inside this register we wanted to enable or we wanted to disable the timer interrupt. So if you wanted to enable the interrupt or you wanted to disable your interrupt, you have to set some values inside the TIMSK. Okay, timer counter interrupt mask registers. Right, so next is TIFRX. Okay, TIFRX is actually timer counter interrupt flag registers. So it means that it is a flag. It means that it will show the current status of the interrupt. Is the interrupt is conducted or it is not conducted yet, which is pending. Okay, that's what the flag register is all about. They wanted to, it's like an indicator lah, okay, for your operation. Alright, now let's take a look on a little bit detail on the TCCRX, timer counter control registers. Sorry. Okay, so in this configuration, we have WGM, okay, 10, 11, 12, and 13. Right, so what is the function of WGM? Okay, WGM is actually waveform generation mode. Okay, so in each and every WGM starts from 000 until 111, you have your own operation, right? If you wanted to use PWM, you have to configure this configuration. Sorry. So if you wanted to use your CTC is actually clear time on compare. If you wanted to do some comparison to trigger your interrupt, you have to use CTC. Okay. Alright, another is PWM and also another PWM and also CTC. Alright. Okay. So the next part is CS10, CS11 and CS12. Okay, so for CS is actually we wanted to configure our prescaler, right? So if you don't want to have any prescaler, you just choose 001. So if you wanted to have 8 prescaler, which is the division lah, yeah, 010 and etc. lah, according to this table. Okay, 8, 64, 256 and 1024. Alright. So next is TIMSK, where I just inform you when you wanted to enable interrupt. So you have to use TIMSK. Okay, timer counter interrupt must registers. Okay, alright. So for TIMSK, bit 7 until bit 3, okay, it is actually reserved. Alright. Okay, so for bit number 2, okay, bit number 2, if you wanted to enable the output compare match for register B. For bit 1, okay, output compare match for timer A. And then last one is TOIE0 is actually timer counter overflow interrupt. Okay, so for the first bit 2 and bit 1, okay, if you write it into 1, right, and also the I bit inside the status register is set, okay, it means that the interrupt bit inside the status register is also set. So the interrupt will be running, okay, if you have some comparison in timer A. Okay, right. So similar to bit 2, if you have some comparison in timer B, okay, it will trigger an interrupt. Okay, but for bit 0, okay, for bit 0 here, if your timer is overflow, it will trigger an interrupt. Okay, so that is how 3 types of interrupt is being initialized lah inside TIMSK 0. Okay, right. So for example of the timer, okay, so to calculate the timer frequency, for example 2 kHz timer by using timer 1, okay. So the normal frequency for Arduino, the maximum frequency is 16 MHz. Okay. Maximum counter value is 256. It means that for 8-bit timer, they can only count from 1 until 256. Okay. But for 16-bit timer, it can count from 1 to 65,536. Okay. Lot more counting can be done. Alright. So, for example, they are choosing the prescaler, okay, of 256, and then they are dividing the CPU frequency through the chosen prescaler. So, this is the CPU frequency, okay, 60 MHz, and then this is the prescaler, and then they will get 62,500, right? 62,500 it is actually the counting that you have chosen for 16 MHz. Okay, so 16 MHz, you have to divide the results through the desired frequency. Okay, so this is 62,500 divided by 2 Hz. Okay, that's, you wanted to initialize the timer of 2 Hz here, and you get the 31,250. Okay. Verify the result against the maximum timer counter value. So because you have calculated 62,500 is actually maximum counting for 16 bit timer. Okay, so if you wanted to initialize 2 kilohertz timer, the counting is only up to 31,250, which is still less than 65,536. Okay, that's why you have successfully designed the 2 kilohertz clock for your applications. Alright. Okay, so next is the interrupt interface. Okay. Alright, so the program running on a controller is normally in sequence. Okay, so basically if you are running a Arduino program, you have void setup. Okay, open and close, and then you have void loop, right? Open and close. Okay, so it will running in sequence. So up until down until you finish lah. So for void loop, we will looping over and over and over again. Okay, so an interrupt is actually an external event that interrupts, okay, the running program and runs a special interrupt service routine. So after the ISR has been finished, the running program is continued with the following instruction. Okay, so for example, inside void setup, okay, you have interrupt, attach interrupt. Okay, so you have attach interrupt in your void setup. Okay, and then you have what is the function that you wanted to, attach interrupt. What is the interrupt service routine? ISR, and then falling edge. Okay, so this ISR or interrupt service routine will be interrupted if it is being triggered. Okay, and it doesn't care what your program is doing. Okay, so it will just go directly to your ISR. Right, so after they finish executing the ISR, then they will go back to your program. They will continue again from where you left your program before the ISR. So that is what interrupt. So it will interrupt your program to run what is actually inside the service routine, interrupt service routine lah. Okay. Alright. So interrupt can be enabled or disabled with the function of interrupts or no interrupts. Okay. So if you wanted to enable, you can use interrupt. Enable interrupts. No interrupt, it means that you disable. Okay. Alright. So by default, the interrupts are enabled. Okay, so this by default lah. If you didn't initialize anything, it means that your interrupt is enabled. Okay, so when an interrupt occurs, a flag in the interrupt flag registers. So because flag registers, they are actually indicating the current status. So if you are initializing interrupt, the interrupt flag will be set. It means that it will become 1. Okay, so this interrupt will be cleared automatically when entering the ISR. So when you enter the ISR, so this is a ISR, you enter inside here, automatically TIFRX, okay, will become 0. Alright. Or you can also manually clearing the bit. Okay, so you can just also write the bit manually lah. Okay, you can also write TIFRX equals to 0 to disable the interrupt. Alright. So inside Arduino, to enable interrupt, you have to put attach interrupt. And to disable interrupt, you have to put the syntax of detach interrupt. Okay, they can only be used for external interrupt pins. Okay, so basically the normal operation that we do is external interrupt lah, where we will generate interrupt from our sensors or our actuators, so any other environment condition. Okay, that is usually the usual thing lah. Okay, if you want to do interrupt in Arduino applications. Right, so next is timer interrupts. A timer can generate different types of interrupts. Okay, so the register and bit definitions can be found in the processor data, and the suffix X stands for timer number, and suffix Y stands for output number. Okay, for example, TIMSK1 is actually timer 1, interrupt must registers. So 1 is number of timer lah, timer 1, timer 2, timer 3. Okay, and OCR2A is actually OCR for timer number 2. Okay, and A is actually output number. So it means that they have A and they have B. So it means that A have a few bits, B have another bits. Okay. Alright, so next is timer interrupt registers. Okay, so for timer interrupt registers, as I just explained in brief in the previous one, for the first one is timer overflow. It means that when the timer has reached its limit. Okay, for example, timer counting only 2, 5, 6. Okay, and then they count from 1, 2 until 2, 5, 6, and then suddenly they count 2, 5, 7. So at this time, they will trigger timer overflow interrupt. Okay, so because they have overflow the counting of your timer, so maximum is 256, and they count 1, 2, 256 until 257, they will trigger the timer overflow interrupt. Okay, alright. So output compare match is actually when I just said they wanted to compare the match interrupt occurs. You wanted to compare the output. Okay, the output between two. We call it two output. Okay. So when the output compare interrupt enable bit in the interrupt mask registers is set, the output compare match interrupt service routine will be called. So they will call lah the output compare match interrupt routine. So last one is the timer input capture. Okay, so for this one, as I just said, okay, rising and falling age. So this is rising, this is falling. Okay, so if we set rising age, every rising age, they will trigger interrupt. So if we set falling age, every falling age, we will generate an interrupt. Okay, so that is what the timer input capture interrupt. Right, so the Arduino function attach interrupt, okay, and detach interrupt can only be used for external interrupt pin. Okay, so 2 pins can be used external interrupt. So if you have if you have a questions inside your test or inside final exam, and the question asks you to attach interrupt to Arduino pins, so you can only use pin 2 and pin 3 only. Okay, pin 2 and pin 3 only. You cannot use pin 4, pin 5, no, because only pins 2 and pin 3 which is used for interrupt. Okay, so the interrupt is enabled through the following line. Okay, so attach interrupt, okay, interrupt function mode. Okay, so for interrupt 0 if you put in pin 2, if you put 1 it is pin 3. Okay, function is your ISR, okay, interrupt service routine. So you can rename lah your ISR as you wish. Okay, if you wanted to do, for example, do encoder ke, calculating, counting, so the name is actually subjective. It is up to you. Okay, so mode is actually you have falling, you have rising, or you can also have changing. So for changing, every changes. Okay, every changes, for example, every rising and every falling, it will trigger interrupt. Right? Okay, so this is the example for timer and interrupt. Okay, the first example is blinking LED with compare match interrupt. Okay, so for this one, first you have to initialize your interrupt in void setup. Okay, and then this is just the pin mode. You initialize as output, and then first you disable all interrupts because interrupt is generally being enabled. Okay, so TCC R1A, TCC R1B, timer counter. Okay, so this is just the initialization of timers. Okay, and then this one, all right, OCR1A is actually compare match registers. Okay, So this is actually the counting lah. Okay, and then TCC R1B, you are setting the CTC mode, and TOIE1, you are setting the prescaler. Okay, and then inside the timer mask, timer 1 mask registers, okay, you are enable the timer compare interrupt by setting OCIE 1A with 1. Okay, and then you put interrupt, okay, because you wanted to enable your interrupts. And then this is your ISR lah, interrupt service routine. So in your ISR, you are going to toggle the LED pin, and then this is just your loop. Okay, alright. So this example uses the timer 1 in CTC mode. CTC is actually clear timer on compare, and the 90 compare match interrupt to toggle LED. Okay, so the timer is configured for a frequency of 2 Hz. So the LED is toggled in the interrupt service routine. So if you wanted to do some compare mesh interrupt, you can use this example lah. Okay. So next is they are doing the same thing, but they are using the timer overflow interrupt. Okay. So the counting is just the same, preload the timers. Okay, but the prescaler is also the same. And this one they enable the TOIE1, okay, to enable timer overflow interrupt. Alright. This one they enable the OCIE1. This one they are enable the TOIE1 to enable the overflow. So that is the difference between example 1 and example 2. Okay, and then they enable the interrupt. So this is the interrupt service routine. Alright, and then they are toggle the pin lah, toggle the LED pin. So they are doing the same thing. But this time it will only being triggered after the timer is being overflow. Okay, after, if the counting is 34,287, it will goes inside the ISR. Okay, so that is how your timer overflow interrupt is being work. Alright, how does it work? Okay, so this is just the circuit lah, which reflecting the next example. Okay, so the next example is actually we are using IR LED and IR phototransistor to implement an optical tachometer. Okay, the IR LED is connected to pin 13 and ran continuously. Okay, pin 2 interrupt 0 is connected across the IR detectors. Right, so for this one we wanted to count. It's like an encoder lah. They are imitating how encoder works. Okay, so by measuring the rotation per minute. Okay, that's why you have RPM count. They are counting the RPM values. Okay, this is RPM and this is time. Time is just they wanted to calculate the RPM lah. Without the time they cannot calculate the RPM because RPM is revolution per minute. Okay, so this is just the initialization of LCD. Okay, and then this is the RPM function. So this is the ISR. Okay, so inside the ISR they are counting up. Counting up. Okay, they counting up this one. Alright, the potentiometer. Okay. Alright, let's take a look on the program. So inside voice setup, they are using attach interrupt because they are using external interrupt. External interrupt is the interrupt that comes from the environment. Okay, it is being connected to pin number 2. Okay, right. So next is this is interrupt 0 because it is connected to pin 2. RPM function, it is actually the ISR for the interrupt, and every falling edge they will count up the RPM. Okay, right. So this is just to turn on your LED, pin mode, output, and digital write. In general, it will high, and we initialize the RPM values. Okay, so inside the loop, they will delay 1000, and then here they are detaching interrupt. Why? Because they doesn't want your interrupt to interrupt the process of your calculations. So if interrupt functions interrupt the process of your calculation, there may be some lines of your calculation wouldn't be calculated. Okay, maybe it will be wrong because the calculation cannot be interrupted lah, because they are calculating something based on the RPM count, right? So they need to have a static value of RPM count, as you see here. Okay. Alright, so for this one, they are just counting RPM, okay, according to these equations. Alright, and then they just clear the LCD and they attach again the interrupt, okay, to get the current state of the counting. Okay, so that is how the timer and interrupt example is being conducted. Right, so it can conducted internally and it can also conducted externally. Right, so I think that is all for chapter 6. Okay, thank you very much. Assalamualaikum and have a good day.